So there's a couple of, so in the center of Crowbar, when I say Crowbar, it's going to mean Crowbar 2. Crowbar's job is really around bootstrapping and orchestration. Right? We all know this. This isn't a surprise. And so what we've done is we've abstracted a couple of things on both sides of Crowbar. One of them is this concept of a jig. And there's already 4 jigs in the system. And what a jig's job is to actually do work. And it actually does inventory. It brings back inventory. It's basically your interface to the outside world as a jig. So no surprise, we have a jig for Chef that interfaces to all the Chef. And then Chef actually works through cookbooks, nodes, and roles.
And the parlance of a jig is roles and nodes.
Yes.
Okay.
That shows up on this side.
What those roles actually mean is abstracted away it's said down in the jig somewhere.
It's a jig's job is to translate between Crowbarisms to jigisms, right? Now, since we are using Chef as we have a whole body, 80% of Crowbar is really Chef. A lot of what we're trying to do is, we're going to communicate with Chef very cleanly, but it's abstracted so you can do other things. So there's another jig called a script jig. And the script jig is really an SSH session. So what the script jig does is it SSHs to the target system. It copies over some scripts. It executes those scripts and pulls back the result. And we use it to set up Chef. Pretty much the only thing we use it for.
To set up Chef?
And the Chef client.
Now, in the old way, those things were in Sledgehammer, right?
Yeah. They were in Sledgehammer or laid down by default by the installer.
But they're not like that. It's not like that anymore.
No, we actually use the Chef roles to install the Chef script, and so we actually have one of the things you could do is you could actually remove the Chef client role, and so there's a concept. One of the things that you'll see down here is that there's actually now real Chef-server and Chef-client roles, and we had them in Crowbar 1, but they didn't mean anything. The -client actually means something now. Okay. And it is useful, and I'll explain when I talk about the annealer. This will come together.
I didn't mean to sidetrack you.
Questions are awesome. So the script jig is the most rudimentary jig. It's actually something we saw when we did other deployments, and Greg had hacked this together, and we're like, that's so cool. It became something really critical here. And then the other jigs that we've got are a test jig that effectively does nothing, but does it brilliantly. So we use it for all of the BDD tests. When those run, they run against all their roles execute against the test jig, which is instrumentable. And so we can actually and when you run the simulator, you're actually running the test jig. So you can do all the behavior for Crowbar. You can get output, readable output, basically log output. And then so you can actually do things like inject delays or just, all we're trying to do is if we test at the API, we make a request in the API in our test harness, we want to be able to test all of the logic that goes on in Crowbar. And so that's what the test jig does. It's useful to understand it. And then one of my favorite jigs is the NoOp jig, which turns out to be a very important jig because there are roles that take no action, but are necessary from a precedence order perspective. So you might have a role. The network roles do some of this stuff, where you have a placeholder that has dependencies in it, and I'll get into the role graph in a minute. And you need something to pin some dependencies to, but you don't want it to take any action. And that's what the NoOp jig does. And so jigs basically have only a couple of constructs. So a jig is allowed to run, so it actually gets a series of instructions to run, and it can create a node or delete a node.
So those are the interfaces that every jig has to implement?
Correct.
Run, create, and delete?
Yes. And so what the reason you want create is when nodes are added into the system, they get added through the API, and then every jig is told, here's a new node. If you need to do something with it.
So based on the role, a particular jig may run on that node.
Yes.
Okay.
And actually I'm about to get to that.
Well, they're not bar clamps, so.
So bar clamps end up being really roll bags. So a bar clamp can have a jig in it. It can have a bunch of roles in it. It has UI components. But a bar clamp is really not a very operable. It's a collector. It's a bag.
Well, I meant in reference specifically to when a new node appears, each bar clamp
Right.
has a method that's called with the new node, right? In case it needs to do something with it. At least that's the way it used to work.
It's the way it used to work, but all that's been shifted to roles. And there's a new concept called the deployment, which is important in this.
Okay.
In this
Well,
I'm going to ping John.
I just asked that question because you said a similar thing about jigs with respect to the appearance of a new node.
Oh, sorry. No, they get told that there's a new node, and then they inventory the node, and then there's.
But they're not long-lived processes, are they?
No, they're not. They're queued as part of the Annealer engine in the background.
Okay. So I don't get why they would create a node, but where is the data for the jig when it does an operation? Where does it save the data? Right now, everything is saved in
Chef.
in the node construct, right? Where does
Well, they don't have a database, actual database.
Right. So there,
Yeah.
one of the big differences there's a database. So when there is a discovery process that runs this direction,
okay?
and that discovery process, there's actually a node.discovery, and there's data that gets stuffed in the discovery attribute,
Okay.
and it gets stuffed in additively. So what you do is you put JSON into this, and it does a merge. So if you had three jigs all dumping discovery, I think there is
So
actually
that data
discovery.
isn't structured, it's a bag of data.
It's a bag of data. Most everything in Crowbar is just JSON bags data. And there is an attribute system where you can add a node attribute that is responsible to dig into this bag and present an attribute on screen. That's one of the places where we're still, there's not a lot of use for that except in the UIs. So it's not something we've moved really fast on because it's ultimately just going to replace the UI attributes. And it's pretty simple. It's in there. It works, but okay. Right. So what's happening is that we are effectively, and this is actually a really useful way to think about it. So in order to drive Chef, what you need to do is you need to say this node has a run list of roles, right? So one of the
When you say run list, that's an anachronism, right? I mean,
It's a chefism.
It's a chefism.
Yeah.
So we're saying this node has these roles on it. We still keep the idea of the Crowbar role on the node. And so the main engine behind interacting with Chef or any of these other jigs is that Crowbar, here's the node role. This is handled behind the scenes, but it'll be important when you start migrating cookbooks. What happens is that we take, Crowbar builds up all this JSON data, and I'll explain where all that comes from, and it adds the JSON data into NodeRole as a block. We call this attribute injection. So we tell this one node all the information it needs to execute the roles that we've told it it's supposed to have. So in this
as opposed to searching for that data as the roles are
right.
Actualized.
Correct. We are, by and large, the goal is you can still use search, but we do not want cookbooks interconnected by search for a couple of reasons.
When you say interconnected with each other, that's
With each other by search. Within a cookbook, you could do that, but it's a real bad thing if the Nova cookbook searches for the Keystone cookbook. Because what happens is then there's a hard dependency between those two things. It's really difficult to understand. So what we want to do is we want to figure out those relationships here.
and have the Keystone data in that NodeRole data for the Nova.
Correct. It's injected in, and then the cookbook just goes to its attributes and says, hey, tell me where to find the Keystone information. Now, it's perfectly reasonable to have that attribute search actually, or that attribute resolution actually resolve as a search. So what ends up happening in the cookbooks is you end up with an attributes file, effectively, that resolves all the things you need to, like, so it's actually emerging as best practice for Chef to have an attributes recipe, file.
A default recipe or something that has all the attributes that you can stick in.
Exactly. And so that is emerging as best practice. That way the cookbook stands completely alone.
Well, some of them actually have
I think there is
a file called
Yeah,
attributes, right?
I think so. Yeah.
Right.
But I don't know why that's distinguished from default.
I think we're moving it to the attributes page, not the default page. But the idea is, and this is what we see in the community, is that you want your cookbook to stand alone. You don't want your cookbook to rely on another cookbook being present. And then people go in and they replace the attributes with a search if they want, or they replace the attributes by manually editing them, or they rely on something like this, where we set the attributes for you.
Okay, so in theory, the only thing you care about is attributes, and if the attribute is published by Keystone, you basically tell it where to retrieve it from. But the cookbook doesn't code that cookbook RAID does not depend on BIOS, for instance.
Right.
Right. It may depend on a BIOS attribute, but you tell it where to go get it, and that's what this does.
But in order to provide all that data, like you say, that dependency will have to be expressed somewhere.
So the bar clamp still has to
Yes.
figure that out and do that junk, but it doesn't happen when the recipe is run.
Okay.
I guess.
Yeah.
So there's a flow of data from here, where as we discover things, and there's a huge, the annealer is where I'm going with this. Actually, all that data ends up in roles. And so actually we're at a good point for this. So we actually there's 3 types of data that we're going to track on every node. So there's actually a big graph here. There's a node list and there's a roles list in the system. Bar clamps are just bags, so I don't really care about them as much anymore. Useful for clustering. But basically, the intersection of these 2 points today is called a node role. Right? We had a conversation on the list about renaming this to be something more descriptive. Right? Association was one of the things that was proposed. We've been talking about the word tact or something like that. But the idea is this is actually the operative thing that carries state and data for the system. There is very little, we're expanding this as we go a little bit, but the central operative thing in Crowbar is this node role thing.
So that kind of takes the place of a Crowbar wall for the node?
Well, in the node role, there is a wall which is used for exactly the same purpose. So if Crowbar does something and needs to record data back, ends up on the wall, right? So this is effectively what I would call
Wall plus wall.
it's really inbound data. It's into Crowbar.
Yeah.
There's also system data, which is outbound. So this is set by Crowbar to push out. And there's also
What's an example of
user data.
a piece of data like that?
I'll tell you. IP address.
Say that again.
IP address. So when the network bar clamp assigns a IP address to a node, the place to put it is on system data. It's system assigned information that is sent back. Shoot. Shouldn't do that when I'm recording. That is sent back to the, this is probably nice, that It's system assigned data that's sent back into the system. So anything, and we were originally combining user data and system data to just data. User data is set during the proposal. These are actually the same. They actually have the same schema. That's not true, because you override them. You do different things. But the system data is set by the roles information and the code within roles and bar clamps and whatever they do. So bar clamps own system data. Users own user data. That's what you mess with.
Okay, so that's that's configuration of the various workloads.
Right. And you can actually default it at the role level and override it at the node role level, which makes perfect sense.
So like inbound data would be inventory information, or like the rate topology would that be the wall inbound? Right now we store like rate topology on the wall.
Yes, and
Controller drives, and that would be there.
it would still be on the wall.
Okay, and the system data would be like the BMC password, for example, which
If you're setting it, it would
we do set it on every node. So whether we set it or not, we still write it on the wall, which yeah, seems like a. And then like disabling a bar clamp would be the user data. For example, if I said that the BIOS bar clamp would not run, would that get written there?
That would actually be done by removing the role from the deployment, or
Okay.
not adding that node to the deployment.
So what would constitute user data?
Adding a node to
User data would be there's a whole bunch of stuff we have in user data.
Like
What
configuration.
hypervisor I want to use
Okay.
would be a great example of one. Or which RAID configuration I want to use.
Oh, okay.
Anything that's user settable on a system basis is going to end up in user data.
and is there utility in separating that from I should say, is there utility in separating that from the other data?
It all ends up
clarity.
mashed together. Yeah, because what we don't want to do is we don't want users messing with system schema stuff. We want to make what the users can change very clear. And part of the way the annealer.
What does that have to do with where you store it in the node role as opposed to the UI?
Because certain of these fields aren't editable at certain states of the node role's life. So they only, so what part of what's going on is there's a state machine, and I have a picture of it, but there's a state machine for node roles, and you can only edit user data when the node role is proposed. Because it's not, so what happens is
what could possibly edit user data when at an inappropriate time?
If they were combined as one thing, then the system. So what happens is when the node role is proposed, you can edit the user data. When you commit the deployment, right, then user data is locked, and Crowbar can modify the system data. Right, because then it's actually, before it starts processing, it has to make some decisions. It puts that in system data. And then once it starts, then it hands it over to the jig, and then the jig can update the wall and make, so it's...
I understand that when you say that it's locked, but what I'm asking is, even if it wasn't locked, who could possibly get to it to change it? Except the user at the UI.
Well, or through the APIs.
Oh, true. So you could accidentally do it through the API. All right.
So what and we didn't start with it like that. We actually started with just data, and we've been separating the concerns.
Right, and that's why I was kind of trying to tease apart your reasons for separating it in that way.
Part of the challenge is that this XML schema gets bigger and bigger, and it's not obvious to the users what they can mess with. And ideally, the schema's at the role level, and they don't even touch it down here. And we'll show you this stuff. And but that's the idea. The main thing in the node role. So the node role has this data, and it has state, right? And there's a state machine that basically says, okay, it says I started proposed, PROPOSED, and this is a user manageable state. When the user commits a deployment, and I haven't talked about the graph. The graph is really important in this case. But when the user commits a deployment, all of the node roles in this committed part would actually are evaluated, and they either move to do because they have no predecessor, or blocked. Now I'm starting to talk about how the annealer works. So when you move, and we're there's a commit action. I have a much prettier picture of this, but there's a commit action, and so you go from you're proposed, you can edit the data, you can look at the deployment, you say I'm done, commit. It's sort of like what we do today. We're trying to preserve some of these concepts. You commit it. At that point, it gets turned over to Crowbar. Crowbar does an analysis. It's going to check system data, do stuff like that, and then it's going to move it. It's going to evaluate what the state of the system, and if it feels like that node role has no predecessors necessary, it puts it as to do. And if it says, oh wait, I can't start this until my predecessors are active, so there's a state at the end called active or error.
Might be more useful to show that as a logic flow diagram rather than like that.
I'm building one up. I have it, but just
No, I mean the current states that Crowbar 1.x supports would be like discover, hardware installing, installing, installed, and then whatever the bar clamp throws on top, like pending or doing something. I mean, how do these new states, do they map to that, or are they completely separate from that?
Completely reworked. So Crowbar 2 had 2 state machines, one of them just to handle node bring up, and one of them to handle, and actually had really no actual state machine to handle node progression, except some weird inspection, left turn, right turn type of thing. There is just one state machine, and it's incredibly, so every node role, you can actually see a graph, and if you go back and look at the videos and stuff that we've shown, this roles nodes grid actually is a graph, and what you'll see when you look at it is a node is in proposed state, nothing can happen. Then when you commit it, it's evaluated to be either to do or blocked, right? If it's in to do, then it can be handed over to the jig. So the jig takes it and it moves it to transitioning. And there's a pretty flow chart for this that you guys can go back to.
So there are a number of different steps that it can go through during transition.
Transition, the jig owns it, right? It's doing its thing, and at the end of transition, it either ends to active or to error. And then after this, we come back and reevaluate to see if there's any blocked that can move to do. So the cycle is, I look at my to-do node roles, I give them to the jig for action, they complete, I unblock the blocked ones that I can unblock, and I keep running through it. And we call it a annealer because it's basically this continuous bake cycle, right?
Now what happens when we have a proposal that sits in blocked state for a very long period of time?
You could effectively, it shouldn't ever happen. That would be basically saying that the dependencies aren't resolved in it. So if it got stuck in block, that's
it could be stuck in block because one of the jigs put something in error, right? So
aha,
you would never ever be able to get out of it. Say like problem state as an example, like hardware failed to set up BIOS because something is wrong. And
so the cool thing is, you would go look at your graph, you would say, aha, I am in error, these guys are blocked, these guys were successful. You can go to that one error, so any one error is going to block everything.
Right.
Go to that error, try and resolve it, and move it back into to-do to kick the annealer back into action.
Well, okay.
Or
So
you actually move back
when resolving it means going into a data center and unplugging the NIC and plugging it back in, and maybe that's a detectable, or maybe what the action isn't detectable by Crowbar. How do you go to Crowbar and say, oh, that error's been fixed?
If you click on that node role that's in error, there's a button
In
that
the
says
UI.
retry, right? Or you can retry them from the
That's
API.
all. That's all.
Yep. No, there's
Because I can see that some things that get fixed we can detect, and some things we can't. Right.
and a lot of times you can. I mean, if you watch the demo, Victor actually does this. Hits an error, he clicks retry. He doesn't use the button. He does the API, and it fixes whatever the timing issue was that he had, resolves itself, and then the thing all completes.
So do we have any timeouts or any mechanism built in to prevent a deadlock condition?
yes, there is actually a resolution for deadlock that Victor added into the system. But it is not a high-level concern because we are expecting to test these. And so I'm not trying to make these super deadlock aware, because what I'm assuming is if you write a set of roles that are deadlocked, we're going to find it in test. Okay, I'm not trying to prevent you from running the scissors. And I haven't explained role relationships yet. I'm backing into that, but I will, because you have to understand how it determines to do versus blocked. That's core. But this is the effective annealer session, right? The jigs own it here. The user owns it here. Crowbar owns it in the other states. And so the whole of Crowbar thinking, right, is these node roles. Basically, you set them in place, you know the order they have to run in, and then you feed them to the jigs in a reasonable, in an annealing sequence, right? This goes back to a conversation that Wayne, you and I had with Ward, where we were talking about, okay, whoever can go first steps forward, we wait until they're done, step forward to who's next, step forward, it's that baking. It's linear baking process, and so that's really what's going on here. It's just churning through that, and consequently, it's really actually very simple. The status of a deployment, we just changed this to make it added. So the way this all goes, I'm going to erase this and this. Take out a little bit. So the way this works is there is a concept of a deployment, a top level thing, and we're working through having deployments have children. So there's a scoping, but a deployment is a scope boundary, if you will. So all the nodes get discovered and stuffed into a deployment. Deployment has something called snapshot, which is a point in time of that deployment. So when you make changes, you're making changes to, and it's a list. Deployment points to the head of the snapshot list. That is where you can make changes. You'll always make changes to the head. And then when you commit, what's happening is it changes the state of the snapshot into the next.
We talked at one time of the issue of being able to move that. Right now, you said deployment points to the head. We talked about being able to move that further back in the list and change something that's further back in the snapshot history.
Totally can do that in time.
Okay. So you haven't. We're not doing that yet, but you have disallowed
it's a very exciting feature.
Yeah, okay.
But we are not working on it.
Okay. Cool.
There is so much capability of extension. We're trying to be very careful not to get excited about.
Just curious.
But yes, you can entirely fork this list and move back to other points.
So the deployment would be like, keep going back to this, but like a hardware install would be considered a deployment, or is it end-to-end getting?
It's like I have deployed MySQL on these two nodes with these configuration options, and once you've actually committed to doing that, and the jig is off for doing that, and it finishes, there's a deployment that represents the state of those two MySQL installations.
That would be complete. The deployment state would be complete.
Yeah. So there's an implication that from commitment until completeness, there's an ambiguity, a period of ambiguity.
Okay.
And
that's definitely, but some of it's just scope. So
yeah.
if I have the system deployment, it's the parent deployment. It has everything in it. And then the idea is that you might say, all right, I'm going to have my DNS server my DNS role, and DNS server is actually part of my system deployment. And I might have an NTP, and all the services in here. But in here, I might have a SQL server that these guys don't see. So the SQL roles would all be in the OpenStack deployment. And so it's a scope boundary. And then I could actually have another OpenStack deployment with a separate SQL server in it, and it would consider those as separate servers.
The deployment is logical aggregation of all the stuff that you're going to do, but the snapshot, does it actually capture what all was done to the systems? I mean,
Yeah.
It does.
Okay.
So underneath the snapshot is actually where we have NodeRoles. And every time you create a new snapshot, you actually create a new NodeRole graph. So there's actually a graph of the relationships between these NodeRoles is part of the snapshot. So when we move forward in time, when we basically take a snapshot to an active state. All of the NodeRoles are active.
So snapshots do not share any data with other snapshots.
That's right.
It's unique to the particular node.
Well, deployment can be a set of nodes.
Yes.
So that can be a really fairly giganticus
It could be.
data constraint.
It's going to be
Not that I have a problem with that.
No.
I'm just in my mind. I'm
this
clarifying.
set is R times N. Right, so the number of roles times the number of nodes. So if you had 100 roles and 1,000 nodes, you have 100,000 entries in this, plus the graph relationship entries in it. In data terms, it's still not that big a set.
No, it's not.
So and then deployment roles are effectively the data, the override, the defaults for the roles. So when I look at a vertical column in the roles table, I want to have intelligent defaults. It's a template, if you will. We actually call it template in some places. So I want to be able to say that this role by default is RAID 10. You put that here, RAID 10, and then all you have to do is override the ones that are
So
different.
what do we call those parameters?
Those are deployment roles. We call them deployment
The
roles. Right?
attributes of the roles?
Their role, their user, they're basically role data. Their user data for the deployment role. And I assume if we change this name, we will also need an appropriate alternate name for this.
Or could be system data for the deployment.
The
It could be
deployment
system
role is a specific role.
The deployment role is the role template for a node role. So if you choose not
So there's one per role.
in each deployment.
Okay, so and it's just the default set of default data for that role.
Correct. It'd be better to call it default role.
And the node role simply contains overridden data of the template role.
Exactly. Good. Keep touching this to make sure I use the screen.
Where do we store the default user attributes, user data?
The defaults of this are actually stored in the role. So the role actually contains a template that gets loaded when you
With
import the
default.
marklet with the default information in it. And then when you create the deployment, it then sets this information.
So the data that's displayed in the UI that the user can change, is that simply part of the
It's,
deployment role data? template
it
data?
starts with this, and if they modify it, it gets stored into this.
Okay.
It gets merged. So you only have to set the JSON, the overrides that you make. And then it's just, you know how Chef pulls together, sort of builds up.
Is
this
that
JSON?
true of these types of data? I mean, this type of data as well, the system data in here?
The system data is injected per node role. There's no override. There's no need to do that
Because it's generated.
because it's
Done.
generated.
Okay.
So
Gotcha.
only the user data has that behavior
I see.
right now. I don't see a reason to change that right now. But it wouldn't be hard to change, but so when you read out the user data from a node role, it actually will merge the deployment role data and the user data, giving the user data preference, just like Chef. Chef does the same thing.
Yep.
And then you get, if you ever ask for the user data from a node role, you always get a complete set, even if you haven't modified it. Because what it's doing is it always provides a complete set of data.
The node role data, is that always a complete write of default plus delta?
Yes.
Never just the delta?
There is a way to get just the delta if you want to see it. But when you look at it, by default, it's going to show you actually, in the API, it's going to show you the delta. In the UI, it actually merges them together.
Do we encode that with sequence IDs so that we can track how we changed over time?
Yes, because of the way node roles go. When you change a node role, you only go from you never go back to proposed. If you want to repropose a node role, you're creating a new snapshot and you're creating all new roles, all new node roles.
So it's the sequence of the storage of snapshots under the deployment that determines the.
That's right.
So you run the same deployment again
So it's
because the node
implicit-
roles were changed.
Wait. You never actually run the same deployment again. What you would do is if you had a deployment that ended to active
Mhm.
and you wanted to change it, you would repropose it, which would make a copy,
Okay.
a new snapshot. You would edit that snapshot and you would rerun it.
So in every deployment and every snapshot and every node role and every deployment role has a sequence ID or a unique ID.
That's correct. So you actually end up with a time sequence of each change you make in the system. It's actually, and it's committed as a body. So we don't commit just one node role at a time, we commit a snapshot at a time.
So what does that ID consist of?
It's just a database assigned ID.
So, I'm sorry, so if you get a brand new node, goes through basic inventory, and then you propose that you're going to set it up as a compute node, right?
Yep.
So your chef jig runs, and it runs through the BIOS parkland, and it sets something. So at the end of that, I would have completed a deployment, got the node into active, the deployment would be active, I would have a snapshot that had all the roles that got you to the compute bus, right? It should be, it would have discovered, it would have inventory, it would have run BIOS, whatever, IPMI.
Uh-huh.
And the deployment roles would basically characterize what would have run and shown the graph. But now, if I say, oh, well, in this, we set the virtualization to enable, but I really want it to be disabled for some reason. And then I create a brand new deployment, edit the snapshot with.
You create you propose
repropose
a new
it,
snapshot for the existing deployment.
Okay, but how would I see the delta between the node state for the last snapshot and now? I mean,
That's an interesting question. We have not, Victor and I have been talking about doing that type of stuff, but we haven't gotten there yet.
okay. Because the term snapshot, like, is now so prevalent that it makes you think it captures the current state of the system, which is what the deployment is altering. The inability to see deltas between snapshots seems kind of counterintuitive to me. But,
It's a great feature suggestion.
It seems counterintuitive.
the inability to see it seems
Oh, inability.
Yes, yeah.
Yeah.
You would want to be able to see the progression of what you did to the system over time.
Actually, I want to be able to see a time sequence of that.
Correct.
Yeah, I mean, yeah.
So totally yes. We haven't built it yet.
Okay.
It is without, you are right, it is a very cool feature. We should definitely be looking at building
One
it.
question, is that in Crowbar 1?
No.
That's not going to be in the first release of
No,
Crowbar.
that's
Well,
right.
I mean,
But it's still a great feature.
designing it, and we need
Oh,
that. Yeah.
blast.
So I mean, everybody, this is the thing that I love about this is that I think we've got a great underpinnings, and then the potential to crank out amazing features that really add tremendous value in managing deployments is right there. But we haven't, nobody's missed out on the design conversation for it. It's like we're leaving lots of open territory.
So, and the status of each deployment, as in what happened during the run, where is that captured? I mean, right now we have an obvious hole with error
Sorry,
reporting.
there's actually another thing in here called log.
Okay.
And when the Jigs job is to put log data in. And so one of the things that Victor loves to show right now, because it's awesome hot, is at the level of the node role, we expect the Jigs to provide log information back into that node role.
Isn't the log part of the deployment role, or no, the node role?
It is part of node. Sorry, this is node role. So I've been building that.
Okay. I know.
Yes.
So, in the when one commits a deployment,
Yes.
and there's a whole bunch of steps that might happen before that deployment becomes active.
Totally, yes.
Right. So there may be hardware configuration, other kinds of things. So it seems like there's a whole set of state machines that happens just in that,
I like
in
where
the
you're
activation of the deployment.
Yes,
And so, but you haven't really talked about that.
I haven't yet.
Okay.
That's,
But-
that's,
but
that's
see,
next
But
topic.
is that similar to the kind of state progression that the 1X Crowbar does with discovering, provisioning?
All those states are gone,
Yeah.
but it's the gating through those states is still present.
And
But
is
there-
it
there'll
by
be
the same
roles.
machinery where a node assumes a set of roles and then it's consequently other sets of roles until it gets to the end?
Yes, it's so you're actually at the next thing.
Okay.
Um,
Because the changing set of roles that a node assumes is kind of a subtlety that most people don't understand.
and,
The
and,
machinery.
and we are going to make that front and center transparent in the machinery.
Okay.
So this is absolutely critical, and this is actually a good bridge to the next section. So one of the number one things we wanted to do was that everything that has to happen on a node, right, from bootstrapping up, is actually a very concrete step with a very concrete success fail. So all of those states that you described in Crowbar 1 are actually node applications of new capability onto that node that we should be closing the loop on rather than just throwing back a intermediate state. And so, I'll get there, but
Sorry,
I want
I have a
to,
quick
no,
question.
ask questions here before we
So
get
the
there.
deployment is still, right now, one of the fundamental holes we have is, in my mind, a lack of clear error reporting on what happened at, say, hardware installing. You're either in problem state, and the only way to figure out why you're in problem state is to look at an incredibly long log that hardly makes sense to me most of the time, unfortunately. So the fact that you can reflect a log back to it seems good, but do we have a way to say that you could be in a state, like, let's say you had multi-controller RAID support, which is kind of there right now, but you fail to set up RAID 10 on the first controller, you fail to set up RAID 5 on the second controller.
Okay.
You could still survive and put an OS and install it and put OpenStack and everything. You just would not realize that you messed up something. Do we have that level of granularity to see which role failed, and maybe that's acceptable? Or because the resolution may not be possible, right? You're in an error state, you can go back and hit your annealer, but it may not fix it.
So you're right. If there is nobody depending on that, so this is a little bit of shade of gray. We've talked about this, but our first pass is to implement things that have clear dependency chains.
Okay.
What you're describing is a node role with no children, and if there's nothing downstream for that node role, then that node role isn't necessarily blocking the annealer from continuing. So realistically, the error state does not block the annealer.
Right, but
It
how do you know
blocks
that
the
something
children.
went wrong, right? I mean, this is possible even with BIOS. You set like 300 settings on the box, and one setting doesn't work.
The Jig's job is to report back the status of every node role. So the Jig, if the Jig can't determine that, then it's going to report success incorrectly. So it's the Jig's job to say, you
Right.
asked me for this role, I couldn't do it.
Right, so like in BIOS, there's a maximum of 3 retries or something, and then we move past and we try to go on. Let's assume that we have some sort of logic because there is a BIOS setting that really doesn't matter whether it gets set or not, but we tried our best and we gave up.
Sure.
Is there any way to, what the jig reflected, is there any way to see that in the deployment, that this deployment succeeded, but it had minor errors or logs that, do you
Yes,
see
that's a
that at
really
all here?
interesting capability. We haven't surfaced it with that yet. It's a
Run
good
that
idea.
by us again.
So you try to set some setting on the system and it doesn't work. But I don't really care whether the SATA controller is on or off, right? We tried 3 times, the BIOS part time said, I tried it, good faith, it didn't work, I'm just moving on and I'm going to try to go with RAID next.
Yeah.
RAID doesn't really depend on the embedded SATA controller because we're working at the RAID controller, the integrated RAID controller level, right? But at the end, your deployment is going to be successful because you still have an OS, you can put OpenStack on it, everything's gravy. But how do you?
I think there's 2 things. One is we haven't had any comprehension of a warning state yet,
Okay.
but there's a different thing that you're describing, which is, realistically, you actually don't care about that node role if it can fail and you could still deploy. So it's not actually part of a dependency chain. And I need to get to dependency chains, and that'll answer that question. Because it actually ends up being a really important thing. And then there's some interesting stuff.
I think he's actually raised something that's potentially critical to us. If we send a RAID bar clamp off to configure the RAID controller and it fails.
Correct.
It fails because really that particular configuration can only do a JBOD configuration. We're still capable of deploying, but not the way that we originally.
But in that case, it would be sitting on error state and you would be trying to rectify it. What I'm talking about is something minor where it goes past, but you still want to know that not everything is perfect. There are minor issues, and
it's a pass. It's a pass with exceptions.
Right. Yeah. At minimum, I'd like to know that the RAID job started at X, finished at Y, but it had these three minor.
So what I would suggest. We need to think about that more.
You need a cascade logic handler of some sort there.
You just scared the crap out of me. We do. Guys, there's a lot of. Our goal is to create the least we can create.
Sorry, I'm not trying to propose design requirements, but
you're thinking, and it shows me that you're digesting the design because you're getting to logical extensions that we are intentionally gapping because this is emergent design. You could actually inject that back into the node discovery. There's plenty of ways we can absorb it, or it might need to be a new state in the state machine. That's all those things are open. It could be that you write it back on the wall, and then we actually say, hey, there's a warning, there's an errors flag in the wall. There's a lot of ways to solve this problem. It's a great use case.
I was just trying to identify what part of the system would do that cascade handling.
The annealer ultimately needs to be responsible for it.
Yeah.
And because one of the ways we designed the annealer was we said we can't do smart orchestration. What is the required dumb orchestration to get done? And that's the annealer. And the more I've played with the annealer, the more I think that we have done actually a lot of really useful dumb orchestration, and it might be enough for most cases. And so I want to keep working through that. But this is the key thing. You have to understand snapshots create this timeline, and then NodeRoles are copied for each time. And so after a deployment's gone active, you create a copy of it, you modify that copy, and then you reapply it.
So you can attach a deployment to a new guy. Would that be a way of
attach a deployment to a what?
Well, you do a deployment on a node, and I want to perform the exact same operations on another node, basically saying this node is a mirror of node X that I just deployed half an hour ago.
We could definitely do that type of. We could definitely say put the same role, copy these node roles onto mirror these node roles. Boom, that would be a really easy operation.
Well, so yeah, so let
We've
me
spoken about this, right?
let me recast this question. So right now, if you had a deployment of MySQL, you might want to go in and say, I want to add another node that also has MySQL. You go into the MySQL bar clamp and you add another, you select another node as a MySQL server, and you save the deployment and you do commit.
Right.
And then it goes out, and now you have two nodes provisioned like that. Well, that's a different approach to saying, what he and I had discussed before was when you have a node discovered, being able to say, see this node, make this one like that one, and not have to go and because it may be that you would add a node to several different deployments when it's discovered.
I think if I can.
But I'm just saying, this is kind of an inversion of from a UI point of view. How do you describe what roles a node takes on?
So let me answer that, and then I need to do this, but I have to stop in 15 minutes. So I'm gonna roll forward a little bit. Yes, to this use case, the word inversion is the key word. In Crowbar, we spent a lot of time. We spent a lot of time putting bar clamps, proposals, nodes, and proposals, and doing all that stuff.
Yeah.
In Crowbar 2, it's almost inverted. What you're really doing is you're putting a deployment or a node into a deployment by assigning a role to it. So the first time you start playing with it, it's going to feel really, because when you're going to look at the deployment, you're going to say, I need this node to have this role in it. And what you're just describing is, hey, add this node to this deployment and put it in the same roles as that node. And that is like the most logical operation in Crowbar 2 I can imagine. Because what you're really doing is you're saying, here is a node. So I'm visualizing a grid, right? So I've got a grid in here. I
didn't really express it.
No, I have a subtlety there. I mean to drag you away from it, but
right.
You have a notion of a reference server in data centers where they believe that something is their gold standard and you are not. Now, Crowbar enforces the gold standard. We carry updates, we try to update you to whatever we do, and that's not always what people would like, right? So part of what we discussed is saying, this is my gold standard, make my other servers look like this with respect to maybe BIOS, RAID settings, and that. So I may have configured RAID manually and not use Crowbar to do it on that node. So it would not have a RAID node role, it would not have a BIOS node role because I did it manually and it doesn't match Crowbar. But I need to be able to suck at settings and apply it to everybody else because then I never have to come up with a new RAID configuration.
Use cases. Yeah,
No,
that's cool.
It makes my life easier. I don't have to come up with a RAID 5.
That's a real life scenario.
It is, yeah, because I keep getting requests to say, we have a thing that has RAID 10 on the back 2 drives, but what if the back 2 drives don't exist? I have no way of handling 82 different configs, right?
I think that, keep thinking through those use cases. I think that we can absorb those pretty easily because what you're really doing is you're saying, configure my
Because that's a real story
user
for
data.
supporting non-Dell hardware too.
Yes, because you may not have those roles on it, but you still want to kind of take what you can apply, right?
Please document what you've just.
I sent a giant list, but not in the context of NodeRoles to Simon and Arkady, but the deployment server.
What you're describing is really cool stuff, and I think you'll find that it's manageable to do in this. But once again, it's downstream work. But yes, that's pre-populating the user roles based on discovery sounds awesome to me. Because that's what the user data in the node role based on discovery, and then cloning that.
Right.
Yeah.
Heck yeah, that's awesome. And then one of the things that's cool about the script jig, or even the chef jig, is that you put the chef jig on, it discovers a whole bunch of stuff, and then you could scrape that and create.
You have to create the new node role for that.
But those are very manageable things to do.
Okay.
All right. Okay.
Sorry.
It's hard, I know. And this is the thing. There's so much capability that we can build in this because it's much more coherent of a model. It's like, because with Crowbar 1, it was like, breathe on it wrong and the whole thing falls apart because there was no master, I hate to say master architecture because it's much looser than that. There was no engine schema that ran all this stuff. And so it's so much more extendable in this case. So the nodes belong to roles, belong to deployments was a huge inversion that has been a really big deal for this, right? The concept of proposals being at the deployment level is a big deal, right? Not at the bar clamp level. Big deals. The other thing that is very explicit in this is that we actually have a very specific role to role dependency graph. So when you import a role, you say, my role depends on these roles. And I realize I'm just using
and that reaches across bar clamps, perhaps.
It reaches across bar clamps and jigs. So a role is specific to a jig and also a bar clamp. Although
but that's expressed in the bar clamp configuration.
It's just in the role config. So bar clamps are just a bag for roles. So when you import a role, that role can only be executed by one jig. It is okay that role could depend that one role could depend on a role that's run by a different jig. Perfectly fine.
I just wanted your verification that the connection between the jig and the role is expressed somewhere in the bar clamp.
In Crowbar YAML in the bar clamp.
Okay.
Yes. So when you import the bar clamp, it imports the roles and the jigs actually. Those are expressed.
And the jigs are implemented in bar clamps.
Yes.
Okay.
So the chef
So I can write bar clamp with a new kind of jig.
Yes, you can.
But jigs aren't a separate thing from bar.
Right. So the Crowbar bar clamp itself implements these 3 jigs, and then the chef bar clamp implements the chef jig. And so, because it also has to set up the chef server. So, and the chef server is actually set up using the script jig, because
So we should be adding another jig operator, and that's Papa to at a later date.
whatever which ones we choose, or somebody could write one that interfaces to
Salt.
switches or salt or to your inventory. So you could actually do it as an inventory. So if you have an inventory system that has the inventory data, you can actually put it in here and then add a role. The trick is, if you want to exercise a jig, you have to have a role tied to that jig. And one of the important things is we actually have, remember we had conduits? There are now network roles that are created dynamically. So when I go into Crowbar, one of the bootstrapping operations is it creates a network-admin role, and then I have downstream dependencies on this network admin role that can't run until I have this guy set up. So there's actually, and one of the things we've done is late binding is huge. So this relationship is actually not a database relationship. It's actually a string match relationship, as scary as that sounds. And so we don't actually resolve this relationship until you're putting it into a deployment. So you can import a bar clamp that needs roles that don't exist yet.
So are role names a namespace
Yes,
class name, basically?
they are.
We actually only do it just in time, don't we?
We only resolve them just in time. So that, because what happens is, let's say I import the Nova bar clamp, and the Nova bar clamp needs 4 networks set up. Those networks don't exist. They can't exist. So what happens is, when I go to actually execute that bar clamp, it says, okay, this is a network role. I need to go create that. You actually have to create the network role in the system so that you can then deploy the Nova bar clamps. So we do the networks late because they're created dynamically. So it's really.
Is there some initial bootstrapping of like pool management for IP address allocation and stuff, or are we still going to be hand-editing that JSON file that I still can't understand?
That file is dying a death
Okay.
that it deserves. Actually, what's happening is that parts of it, since we're not really changing the cookbook that it runs,
Right. No.
parts of it are being moved into different places. So there's a network-server. The network server role actually contains the NIC mapping data.
Right. I mean, the role is more pertinent to me, right? But from a UI perspective, when you bring up the admin, before you do your first deployment, I would like like a wizard, right? Say, hey, you're going to do a deployment, but my admin needs these IP addresses, your BMC needs this. Do we have that?
You were like the most awesome straight man ever. Awesome.
Terrible.
So here's and actually Scott had the same comment. Victor and I are bringing up a system, and he's like, "What do I actually have to touch? Because we don't set it up for you automatically anymore."
Right.
So there's actually a screen called the bootstrapping screen that will walk you through each one of the roles that you need to modify, create the roles that are missing.
Okay.
Only after you've created the admin network in the UI, then you create the admin server, and it adds all the roles that it needs. And then you tell the annealer, hey, go deploy on this admin server. And it goes through, there's a set of, I think, 20 NodeRoles right now to bootstrap the admin server that start with set up chef, then set up the NTP server, the DNS server, the HTTP server. So it actually, every one of those services on the server and then the client are all actually discrete NodeRoles that get kicked off only after you have done configuration in the GUI or on the APIs.
So in the bootstrapping.
On the bootstrap street.
You probably hit your,
Was it time? Yeah, within 5 minutes. But the takeaway from all this is that these relationships are definitive, right? This is the first thing that Victor pulled down when we restarted. He's like, I am never going to rely on order to resolve dependencies. There's an explicit role dependency graph, and we surface it in the UI, and you can watch the annealer execute it, and this one thing creates huge goodness in the system. And then the annealer actually just picks up and just marches down that road. All right. Good.
thank you very much.
This helped? That was awesome. Okay.
Yeah, it hasn't changed in radical ways from the last time I heard about it, but it seems much more cogent.
There is a video out there for the simulator, about an hour long. If you watch it, which I suggest you do, because it'll walk you through the setup, please take notes in it for it and add timeline notes for it so people can navigate it.
Okay.
And this
And
video
I'll upload this.
awesome.
Thank you.
My pleasure.
You called me into this, Robert.
About